Hi, Martin here with another video, and today I'm going to be explaining algorithms in Swift programming. So let's get started. So firstly for this video, I'm going to be using Swift Playgrounds and Learn to Code. Learn to Code is an interactive course created by Apple within Swift Playgrounds to teach the Swift programming language. So if you don't have Learn to Code, I'll link my video below that shows you how to get it and also goes over the basics. You can also check out my previous videos, which goes over all the other sections in Learn to Code. So in Learn to Code, after the while loop section, we move into the final section, which is algorithms. So as always, first and foremost, what is an algorithm? Well, Playgrounds itself actually gives a pretty good explanation here in the introduction. So an algorithm is a set of rules and instructions you use to solve a problem. So essentially, technically, we've been using algorithms all throughout Learn to Code. So we've been using algorithms to solve a number of different challenges throughout the Learn to Code course. So the final section really is a culmination of everything that we have learned during Learn to Code. So let's take a deeper look at algorithms by going to the first challenge, which is the right-hand rule. So one thing that this challenge talks about is something called pseudocode. So you can see here, it says pseudocode looks a bit like Swift code, but it's worded and structured so humans can easily understand it. So essentially what pseudocode is writing out your instructions similarly to what code looks like, but not exactly. So essentially it should be easy for people to read. It's not designed for a machine or our computer to be able to read. So you can see here, there's an example of how the solution for this challenge, where we need to get Byte to go around these walls, pick up the gems and toggle the switch at the end. So our instructions are, based on the pseudocode above, write out a solution in code for the puzzle, run your code and tweak your algorithm if necessary to solve the puzzle. So essentially what we need to do here is take the code that we're given, compare it with the pseudocode, and then take a look at what we need to edit. If we run the code, and I'm going to go ahead and click on Run Fastest. So I'm going to run the code that we've been given so we can see what Byte can and can't do. So you can see he moves around the first wall, but he doesn't collect the gem and he just stops after that. So if we take a look here, the pseudocode we can see is essentially one for one in this first function, this navigate around wall. However, the second one is actually a little different. So what we're going to do is edit this second function here. So we're going to change it to while is not. So remember this exclamation mark here changes this to not. So while's not on a closed switch, because that's where we know the end is. So we want the code to keep going until we get onto that switch. So I'm going to go ahead and change this is on gem, okay, to is on closed switch. We want to keep the navigate around wall. So while we're not on a closed switch, we want to navigate around wall, which is moving around the various walls that pop up. But what we always also want to do is check if we are on a gem, and we can see that in the pseudocode here. So we're essentially taking this pseudocode and just putting it into Swift code. So if is on gem, we're going to collect our gem, and then we need to turn around. So we have no specific turnaround function, so we can turn left or right twice. So we've got while's not on closed switch, we've got while's not on closed switch, navigate around wall, if on gem, collect gem, turn around, if on gem, collect gem, turn left, which should turn us around. So the last thing we need to do is toggle switch. So once all of this is done, that means that we should be on the switch and we can toggle it. So let's go ahead and run that code and see if it works. So you can see the walls are randomly generated here. So we need to just have the condition if we're blocked on the right, and that allows Byte to move around any wall that's generated. And there you go. So all we've done is our code's been planned out here with pseudocode, And then we've taken that pseudocode and created a function down here. So we can expand a little on this concept of algorithms in the next challenge, which is adjusting your algorithm. So here Byte's no longer just blocked on his right, but he can now have 3 different situations. So he's blocked on his right and front, blocked right and not blocked. So the instructions here explain those 3 different scenarios and then what he should do. So we've got the solution that we came up in the previous challenge. So what we need to do, so it says use pseudocode to think through how your character should move in the 3 situations above. The key thing, particularly with this and with algorithms, is there's no one perfect way of solving this. So you might do it in slightly different ways, but we'll just look at one way that this could be solved. So what I'm going to do is where I've got if is blocked right, I'm going to change that condition and I'm going to make that if we're blocked on the right and is blocked, okay, which essentially means we're blocked on the front, okay. So if that's the case, okay, then we're going to want to move to the left. And we'll keep the move forward. Where I've got the else here, I'm going to move that one down and I'm going to put in an else if. I'm going to change that to is blocked right. So I'm checking, are we blocked on the right and the front? Okay, no. Well, are we blocked on the right? And then if we are blocked on the right, then we just want to simply move forward. Okay, so we've got our move forward here. And then finally, we've got our else, and that would be turn right and move forward as it was. So we've edited this by just tweaking the first one to be is right and blocked and added in the turn left. We've got the is blocked right and then else. So that should check, are we blocked on both sides? No. Are we blocked just on the right? Okay, and then if not, then we get down to the final one here. So we'll go down and just double check the close switch. So that shouldn't change in any way. We're still collecting gems and we're still turning around once we get there, and we're still finishing with a switch at the end. So let's go ahead and run that code and see if that tweak to our algorithm has solved this new challenge. So again, you can see the walls randomly generated, but instead of just going straight up, they're going around as well. But Byte's sticking to the edge, okay? So you can even see here, there's a couple of imperfections in the code, Byte bumping into a couple of things, but it does solve the problem and also highlights, I can go back, I can tweak this, and there's multiple ways or multiple algorithms that you can create to solve this challenge. So there you have it. That's algorithms. That's the entirety of Learn to Code. I hope you've enjoyed this series. If you have, please like the video, comment below, and subscribe for more. Thanks, and I'll see you in the next video.